At 04:12:26 UTC, deep space tracking arrays across 3 continents registered something no one had ever seen before. The signal came first from the Atacama Large Millimeter Array in northern Chile, a sharp deviation in trajectory from an object we have been watching for months. Within seconds, the European Space Network station in Darmstadt confirmed it. 42 seconds later, NASA's Deep Space Network antenna in Goldstone, California, locked onto the anomaly. 3I Atlas had changed. Today, the impossible just happened. Moments ago, while passing just beyond Jupiter's outer magnetosphere at a distance of 5.4 astronomical units from the Sun, the interstellar object designated 3I Atlas appeared to split into 2 distinct bodies. This changes everything we thought we knew. What began as a faint, fast-moving interstellar visitor has now become the most closely watched object in human history. If you want continuous updates as this story unfolds, subscribe now, because what we are witnessing may redefine our understanding of physics, of planetary defense, and possibly of our place in the universe. For months, 3I Atlas had behaved like an unusually dense cometary body, traveling at 68 kilometers per second relative to the Sun, far faster than typical long-period comets. Its inbound trajectory suggested an origin beyond our solar system, possibly from a stellar nursery 200 light-years away. NASA's Jet Propulsion Laboratory tracked it through optical imaging and infrared spectroscopy. ESA's Gaia data refinement teams analyzed its motion vectors. The James Webb Space Telescope focused its near-infrared instruments on the object's surface composition, detecting unexpected metallic signatures mixed with volatile ices. Harvard astrophysicists ran gravitational models through supercomputers. Caltech observers used adaptive optics to refine shape estimates. Meanwhile, radio observatories in Australia and South Africa scanned for emissions across the 1 to 10 gigahertz band. Across 3 continents, dozens of institutions were quietly aligned on a single question: what is 3I Atlas? 48 hours before the event, the first anomaly appeared. Jupiter's immense gravity began tugging at the object as expected. Our simulations predicted minor tidal stresses, nothing extraordinary. But telemetry showed an unexplained acceleration of 0.004 meters per second squared, perpendicular to its orbital path. There was no visible outgassing plume, no asymmetric sublimation, no rotational torque consistent with cometary jets. 11 hours later, spectral readings shifted. The surface temperature rose from 143 Kelvin to 172 Kelvin without a corresponding increase in solar exposure. Its albedo subtly shifted from 0.12 to 0.18, suggesting a modification in surface reflectivity. I remember staring at the data feed as the color index drifted toward a faint bluish hue. Comets redden as they age; they do not turn blue. 6 hours before the split, magnetometers aboard the Juno spacecraft, still orbiting Jupiter, detected a localized disturbance in the Jovian magnetotail. A fluctuation of 19 nanoteslas pulsed at regular 13-second intervals. It was subtle, but it was precise. 3 hours later, the Hubble Space Telescope captured a faint elongation in 3I Atlas. What had appeared as a single 11-kilometer body now resembled a bilobed object connected by a narrowing bridge.
This was no ordinary fragmentation. Comets fracture chaotically under tidal stress. They shed debris irregularly. They produce expanding dust clouds and erratic trajectories. At 04:12 UTC, that bridge vanished. The object separated into two near-identical masses, each approximately 5.3 kilometers in diameter. Both maintained identical velocities within 0.0007 kilometers per second. Both altered course by precisely 0.6 degrees relative to Jupiter's equatorial plane. No natural process could produce such symmetry. 11 hours later, the two fragments maintained a constant separation distance of 2,400 kilometers. They rotated in phase, completing one revolution every 8.4 hours. Synchronized. Spectroscopy revealed something even more puzzling, a reduction in volatile outgassing by 83% immediately after separation. If this were tidal fragmentation, we would expect increased sublimation. Instead, the fragments grew quieter. Dr. Elena Markovic at Caltech proposed the mainstream explanation first. According to her tidal resonance model, Jupiter's gravity could have induced structural fatigue along a pre-existing fault line. The symmetrical division might simply reflect internal density uniformity. It was elegant, but it did not explain the pulses. At 1703 UTC, radio observatories in South Africa detected narrow-band emissions at 4.2 gigahertz, originating from the vicinity of the two fragments. The signal repeated every 89 seconds. 89 is a prime number. At first, it was dismissed as interference, perhaps reflections from Jupiter's magnetosphere, but computational filtering removed Jovian background noise. The signal remained. Dr. Aaron Feldman at Harvard ran statistical randomness tests. The pulse intervals shifted subtly. 89 seconds, then 97, then 101. All prime numbers. This was no longer random. It was responding. Simulations intensified. Gravitational modeling ruled out rotational shedding. Spectral analysis found trace signatures of nickel-iron alloys, uncommon in cometary bodies, but abundant in metallic asteroids. One hypothesis remained conservative. 3I Atlas could be a rare interstellar contact binary composed of two nearly identical lobes, preformed before entering our solar system. Jupiter's gravity may have simply nudged them apart. The alternative hypothesis was far more unsettling. What if the split was not structural failure, but deployment? 24 hours after separation, the leading fragment adjusted its trajectory by 0.02 degrees toward the inner solar system. The trailing fragment slowed by 0.3 kilometers per second. There was no visible propulsion, yet the delta V was measurable. Across control rooms, conversations grew quieter. ESA encrypted internal communications. NASA convened emergency briefings. Data pipelines were isolated to prevent cyber interference. Then came the second wave. 36 hours after the split, the trailing fragment vanished from optical detection for 17 minutes. Not dimmed, not obscured, gone. Infrared sensors saw nothing. Radar reflections returned null results. Then, without warning, it reappeared 430 kilometers from its previous predicted position. No known laws of physics allow macroscopic objects to disappear from multiple spectral bands simultaneously. During those missing minutes, Earth-based magnetometers recorded a faint global fluctuation of 3 nanoteslas. Communication satellites experienced brief signal degradation across high-latitude regions. Airline pilots reported unusual compass deviations near the poles. Coincidence? Perhaps. Or correlation. Meanwhile, the two fragments began emitting synchronized pulses, prime numbers again, 2, 3, 5, 7, 11, encoded in bursts of microwave radiation. Short, measured, intentional. Dr. Raj Patel at the European Space Network argued for plasma instabilities. Jupiter's magnetosphere is complex, he said. Charged particle interactions could create periodic emissions, but plasma does not count. The world's governments were informed quietly. No public announcement was made.
Internally, the object was reclassified from cometary to anomalous interstellar body. I recall watching the simulation screens as both fragments executed a subtle realignment, tilting their axes toward Earth's orbital plane. The separation distance remained fixed at exactly 2,400 kilometers, not 2,398, not 2,403, exactly 2,400. Precision implies control, and control implies agency. Yet we must be cautious. Extraordinary claims require extraordinary evidence. The burden of proof is immense. Still, data accumulated. Thermal imaging revealed localized hotspots on each fragment reaching 310 Kelvin, far above equilibrium temperatures at that distance from the Sun. These hotspots pulsed in tandem with the radio emissions. Energy output calculations suggested internal sources exceeding 10 to the 9 joules. For comparison, that is equivalent to the detonation energy of approximately 240 kilograms of TNT released repeatedly in controlled bursts. No natural comet behaves this way. Global reaction remained muted on the surface. Markets did not crash, headlines remained silent, but inside research institutions, tension was palpable. Encrypted messages passed between NASA and ESA. Harvard's computational models ran non-stop. Caltech's supercomputers simulated thousands of scenarios. The mainstream explanation struggled to keep pace. Perhaps exotic crystallization effects, perhaps unknown interstellar materials with unusual magnetic properties, or perhaps something engineered. As days passed, the two fragments approached a gravitational resonance with Jupiter's outer moons. Instead of dispersing, they executed a coordinated slingshot maneuver, gaining velocity without chaotic spin. The leading fragment accelerated toward the inner solar system. The trailing fragment maintained a slightly higher inclination, a divergence, a strategy. Bird migration patterns shifted subtly over the northern hemisphere. Satellite operators reported minor but measurable orbital perturbations in low Earth satellites, fractions of millimeters yet statistically significant. Again, coincidence cannot be ruled out, but patterns are emerging. I find myself contemplating the possibility that we are not witnessing destruction, but division of function. Two components, two trajectories, one origin. Maybe we're not witnessing a comet splitting. Maybe we're observing a system activating. In the quiet hours after the latest data upload, I stared at the prime number sequence scrolling across the screen. Mathematics is the universal language. It transcends chemistry, biology, and culture. If something wanted to announce its presence without aggression, primes would be a logical choice. And yet, we must remain grounded. Could an exotic natural object mimic intentional behavior? The universe is vast. Interstellar chemistry may produce phenomena we have never imagined. But symmetry, precision, synchronized pulses, these are hallmarks of design. The calm after chaos settled into a heavy silence across the scientific community. No official statement has confirmed artificial origin. None may ever do so. Still, we ask the question, what happens if 3I Atlas splits into two at Jupiter? Perhaps this is only phase one. Perhaps the fragments are probes, one continuing inward, one maintaining observation. Or perhaps this is simply the universe reminding us how little we understand. There's a quiet beauty in uncertainty, a humility. Maybe we're not witnessing the end, but an invitation to expand our physics, our imagination, our sense of belonging in a cosmos far older and more intricate than we ever believed. As I speak, both fragments continue their journey, one arcing subtly toward Mars' orbital corridor, the other drifting higher above the ecliptic plane. The pulses have not stopped. The separation remains exact, and our instruments remain fixed upon them. Because if this was deployment, if this was intentional, then the next maneuver may already be underway.